exciting here and beyond. And I'm going to jump right into it with a game that we call Name That Marine Debris. So go ahead and shout it out. What does that look like to you? Yes, trap? Yep. So this is a lobster trap. We find a lot of these in the Gulf of Maine where we do our work. This is our version of derelict fishing gear. I think what you have here is more of the net nature. Yeah. Okay, I will not insult you. This is clearly a beverage container. Okay, so do you think this is made of glass? Metal? Plastic? When we saw it, we thought, we're like, ooh, it looks like a chalice. Like a ceremonial cup. It was in Annapolis Harbor down at the, just sitting in very bad visibility. And you are right, it was just a plain old plastic cup. Okay, we're getting smaller now. Do you recognize these? The colorful thing. Well, actually, all the big things that are not sand in this picture are the same thing.
Microplastic.
It's microplastic is the big category. It's more specific. Are you familiar with resin pellets or nurdles? You might have heard.
I've heard nurdles. Yeah.
So these are the raw material in plastic manufacturing. This is what a toothbrush looks like before it becomes a toothbrush, or my clicker before it becomes a clicker. This is how plastic, once it's made by the manufacturer, gets transported in the form of these small pellets. And there's incredible loss. They're all over the place. Okay, so this one, a little bonus, we're getting smaller. The yellow thing would just be bonus if you can guess that. But what you're really looking at is this little bundle. Guesses of what this is? This is microfiber. This is little bits of fiber that broke off of clothing. We got it by filtering effluent, the water coming out of a washing machine, pinching a little bit out, drying it and magnifying it and putting it next to a piece of spaghetti. So you can see just how small this stuff is. And we're going to get back to microfiber pollution in a second, but I want to explain who the we is that I talked about. Rozalia Project for a Clean Ocean is a nonprofit that we founded nearly 15 years ago now, and we are dedicated to protecting the ocean primarily by working on the problem of marine debris, and we use 4 strategies. Data cleanups, always with data. So we pick trash up and then dump it back out, sort it, count it, so we know what's out there. Prevention through education programs, embracing innovation to technology, and doing solutions-based research. We work from the surface to the sea floor. Clearly, shorelines are easy to access. I'll show you our awesome vessel in a second, and this is Hector the collector. We don't throw people overboard. I know I'm in the midst of scuba divers. I wish we could. It is prohibitively expensive and difficult for a nonprofit to do even snorkeling. So we do swim call, but mostly if there's work that needs to be done underwater, Hector does it. This, now you guys have seen underwater in real time because you go there. But this is the face that people make when they see underwater in real time for the first time, without being thrown in the water. This is what we call ROV face. And adults make this face too. We've just come, they're looking at the screen. The screen is showing live what the ROV sees, and we just found a bicycle in Jamaica Pond in downtown Boston. Yeah, they don't float bikes, in case anyone's wondering. Looks like fun to ride off a dock? I'm sure it is until your bike sinks. Okay, we specifically and deliberately focus our work in urban, inland, and coastal waters. Respect for all the work that's happening in the center of our oceanic gyres. However, we recognize that the land-sea interface is where the majority of marine debris comes from, and we believe that's where the most efficient solutions are. We have spectacular partnerships and a real diversity of partnerships. Everything from straightforward funding partnerships to being able to write the marine debris curriculum or marine debris lesson plans for U.S. Sailing's STEM REACH program, or university partnerships. You mentioned the State Department and National Geographic and Lindblad. And we're optimistic in the face of an overwhelming problem. We're optimistic because we recognize that this is a very collective we human problem, and we believe that the collective we can get back ahead of it. So this is our beautiful vessel. It's actually more beautiful now because it's been repainted, but we are propelled. Our propulsion is diesel, but nearly 100% of our house bank power has been obtained from solar, wind, and hydro over the last 10 years. And here she is sailing. The hydro is in the water, producing power while we sail. There's not enough drag for a boat this size to worry about. And she is a piece of American sailing history. A guy called Dodge Morgan had her built in the mid-'80s, and he broke the solo nonstop circumnavigation record in 85 to 86, donated the boat to the Naval Academy, and we are her third owners. And she is a delight to sail, and we have my favorite of all of our captains.
Oh, wow.
You know that. Here with us, amazingly, Snark lives here now, so lucky me, lucky you guys. Okay, so we are doing all of this work with an eye towards solutions and goals of solution finding and implementation. So I have this kind of working solutions document. Our strength is in the field side of the very foundation for coming up with solutions, which is understanding the problem. So I consider myself an expedition scientist, and we have great lab partners usually at universities. And we also engage in innovation and redesign and education and awareness. The three types of marine debris that we focus on are really the three big ones. They are, in reducing size, derelict fishing gear, so the deadliest, and the heaviest, and the biggest in terms of area. Consumer debris, the most visceral for all of us because we touch it, use it, are interacting with this stuff all the time. This is packaging and that kind of thing. And then microplastics, which is probably the most insidious and also the least visible. And I'm going to talk more about microplastics in this talk today. So to get us all on the same page, a little definition. So you guys already know about microplastics, but did you know we talk about them as two types? Just curious. No? Okay, perfect. Primary microplastics are pieces of microplastic made small. Our threshold is 5 millimeters and less. For rough estimate, 5 millimeters is approximately half the size of your pinky nail, give or take. So if it started out that small, like a resin pellet, or microbeads, which are now banned in the US, they used to be in facial scrubs and toothpaste and stuff, that's been banned, you have to use natural material now. Glitter is usually plastic, but there is sustainable glitter, algae-based. You can still sparkle sustainably, but it's good to look at the package. And then secondary microplastic, which is when a bit breaks off of something bigger. So you can have fibers that come off of larger ones, little bits of film, like off of plastic bags, and of course fragments. Today we're going to have even more focus on the microfiber part of this problem. Here are some images of fibers from clothing magnified. So they have all different shapes. You can't see this stuff with the naked eye unless you drain your washing machine effluent water and find something like this, filter it. Or honestly, you could also just look at the lint that's caught by your dryer. Electric dryers have the lint traps, but they don't catch everything. So the same stuff that you have in your lint trap, which is basically that, also goes out into the world, and clothes break while we wear them. So microfiber pollution happens because of the combination of the vulnerability of our clothing combined with various mechanical processes like wearing it and laundering it that cause it to break and fall apart. And you can see that different types of fabrics are more vulnerable than others. So none of this is to vilify anything, but only to indicate the differences. And you can see that something like that, which is polyester like outerwear, is very tight weave, low shed, whereas polyester fleece is not very low shed. You can see its vulnerability. Cotton is super high shed as well. This is a pair of leggings. This isn't to say that we should all be wrapped in legging material all the time. This is only to know some of the difference. Now this stuff is ending up in our environment, and it is getting taken on or ingested by a very large amount of creatures. And honestly, this is a very old study, especially for this science. I don't know what the latest numbers are, but I need to update that. And the consequence of creatures ingesting this is a lot, so just don't be afraid. Here, we're going to break this down. So These types of creatures, so these categories, not all of these, but these are examples of each of these categories, can, again, not all, but have a variety of these responses when exposed to a variety of those plastics. And so that is scary. All of the creatures had at least one of these effects when tested in this particular paper. And I am happy to email you all the citations that I use in this talk. So that's an easy follow-up. Now, as far as the other types of dangers that microplastic fibers and fragments can cause to sea creatures, it's twofold, physical and chemical. The physical issues have to do with scratching the esophagus or filling up a little belly with something that doesn't give an animal any nutrition. And then it can't do the things it needs to do, like make more little marine creatures or feed itself, migrate, do what it needs to do. And then, of course, there's the component of toxicological effects related to the chemical side. We are interested in the non-synthetic but anthropogenic, so man-made, fibers and garments just as much as we are interested in the synthetics, because they're not completely off the hook. While dyes and other types of additives are used in our cottons and other natural products, we are interested in that as well because we don't want that in fish bellies. And here's a pretty straightforward example of a cellulosic or cotton fiber leaking its blue dye under a slide. So we caught this in actually one of our Hawaiian samples, and it's stuck under a piece of this special tape under a slide, and we can see that it's leaking its dye. So until we're all like, cheers, and drinking that kind of dye, we don't want it in. I certainly don't want it in our waterways. Now, what the creatures eat, we eat, and studies have been done that have gotten fish from a fish market, so not randomly caught fish, but fish meant for people's plates, and found that 1 in 3 finfish, 1 in 3 shellfish, 1 in 4 finfish, and most of what they looked at had microplastic, mostly microfiber in it. Now, it's not just about seafood because it's actually beyond. Microplastic, mostly microfiber, has also been found in tap water, but also bottled water, honey, salt, and beer. And we're getting to the lowest part of this talk, so we're gonna bounce back up. So we're near the bottom, and we're about to turn the corner, but it is gonna get worse. So it's about to get worse, and then I promise it'll get better. So there have been studies that have tried to look at how much humans are getting. So there's studies that look at animals. Animals have been a little bit easier traditionally, depending on how you like to do your animal studies, but we cannot dose humans. And so this has been a much slower, appropriately slower science. And so this study has looked at what people have ingested and inhaled, and you can see that fiber, the gray, is primarily the issue. And this study looked at how much has been ingested and inhaled by people of various sizes. There are very, very big ranges, depends how you eat, there's a lot of factors, but these numbers are in the tens of thousands, not in the dozens of pieces. You might have already heard this. Okay, now this is the bottom. All of this information that I'm about to tell you has been published in the last, I think, 3 years. So microplastics in terms of humans has now been found in human lungs. Oh, Matisse is my favorite artist, so I'm using this kind of twisted up blue lady to be my model here. So lungs, the heart tissue, throughout the digestive tract, in gums, that was the microbeads. That doesn't happen anymore, I hope. Throughout the reproductive system in both men and women, in their blood, and also most recently in a paper that's about 7 weeks old, arterial plaque. The consequences of finding this in these parts of the body are these associations. We don't have causation. We can't say that plastic 100% caused various diseases, but we can say there's correlation and relationships in these papers. And the the way humans are suffering because of this are on this list. This most recent paper, and again, I have all the citations, is the most fascinating for me. Arterial plaque was removed from about 200 people to make their circulation is in their necks, and someone very, very smartly dissected it and looked to see if there's microplastic in that plaque. 60% of the people who had their plaque removed had microplastic in the plaque. If someone had the microplastics, they had a 4.5 times higher likelihood, 4.5 times higher likelihood of having a stroke, a heart attack, or dying within 34 months of that surgery compared to the people that didn't have microplastic in their plaque. So this is a study with people who were sick, needed some help, and there's a lot more to learn. We knew, and this is all going to get better now, we knew that we needed to work on this problem and get ahead of it even before all of that information was ready. So when we learned about the problem of microfiber pollution, the way I say it, screamed at us. And so we set about 3 goals. We wanted to contribute knowledge about the problem. We wanted to come up with a solution and implement it as fast as we could to help us with the 3rd goal, which was to spread the word to not just students, but to people in the myriad industries in which we have no expertise. And everything from textile design to the manufacturing of fibers themselves. And so that's what we've been doing. I'll go through some of the science that we've done. Our kind of signature science that SNARC was captain for both of these trips was to sample the entire Hudson River, from Lake Terror the Clouds, high in the Adirondack Mountains, all the way to Ambrose Light, where the Hudson meets the Atlantic. And we did the upper Hudson by sort of foot and wading and a little bit of apologizing after, with a little bit of whitewater rafting, and the rest on American Promise. I swear this was not posed. We did air the first time we did it was just water sampling. The second time with National Geographic funding, we sampled the air, the soil, the surface again, and then we sampled with this very nifty device called a Niskin bottle, the center of the water column and 1 meter above the river floor. At the same time, we field tested some new science-enabling devices. If anyone's ever had to do filtering, you'd be like, oh my God, this tape is amazing. We can talk about that later. And an in situ microplastic sampler to take sort of the human contamination elements out. We turned our dining room table into the lab and back several times a day. And we got some really interesting results, I think. They were surprising, especially, so the first time we did it, we expected a heat map to kind of look like the population heat map, and there to be a relationship. But we didn't find any real relationship with population. In fact, we found no statistically significant difference in concentration of microplastics across the entire Hudson River. And that's super weird to us because you're not even allowed to live up there. It's like alpine region, there are no people, and there's definitely not municipal wastewater. At the time we did the first trip in 2016, and even to some extent the second in 2019, the majority of what everybody was thinking was that this is a washing machine problem, washing machine effluent. But to get these results in 2016, we realized that there are additional major sources. And so the study, science often inspires a little bit more science. You pick up some answers along the way and have the opportunity to make some changes, but then there needs to be more information to increase the scale of those solutions. And so I have to say, with a whole lot of joy and gratitude, that the study of this, to understand it, has brought me to do work off of the Nautilus in the Hawaiian archipelago. I have some results from that for you. As far as Arctic Svalbard, and it's funny, I don't know that I've ever seen a Hawaii-centric map. And so when I looked at this, I looked for Svalbard, and I'm like, where's Svalbard up there? Like, where's Europe? But, so Svalbard is up here. So we got as far as 81 degrees north, which is probably right on the edge of the actual, so it's a pretty spectacular map you have here. So that's where that is, Arctic Svalbard. And then all the way down to like nearly off the map in the other side, we went down the fjords of Norway, which are just, like we went from sort of Svalbard to Bear Island, which is in the middle somewhere, and then down like that to Bergen. We went to the Southern Ocean, be still my beating heart as a sailor, what a place to go to. So again, like, I just keep going to the wrong side of this map. It's fascinating how I realize that like all the maps we look at, Hawaii is stuck off to the left, but you guys put it right in the middle. It's awesome. So Southern Ocean to the Falkland Islands, South Georgia, the South Orkney Islands, which were spectacular as a bonus. We didn't even know we were going to go there. And be still my beating heart, Antarctica. It's a bit of a dream. And I have to just share this picture because I love ice. And I love penguins. And this was like, all I could do was to like keep myself from exploding outside of my jacket because it was like all the ice and all the penguins. It was pretty spectacular, I have to say, yeah. And it's, I think it's important that when you get to go to a place, you also like enjoy the place and whatever the reason. So whether it's science or sport or whatever, yeah. So another thing I really love, in addition to ice, is the water here. This blue that I can't even describe and the warm water. So it was pretty great to be part of this expedition on the Nautilus, Ocean Exploration Trust and National Geographic. We sampled, you'll see the map in a little bit, next slide, but we looked at the air and the water, and we didn't find tons, which was pretty good, but it's not really, for us, the amount so much. Look at the breakdown. That's interesting. We found more anthropogenic natural fibers than we found synthetics. That's interesting. Like, so that means more cotton, more human-made cotton. This is where we sampled the leeward side of Maui and around Lanai, with like a few kind of ones out here on the way. And the hot spots are the big circles. So a water hotspot is a big circle with water, and the air hotspot is the big air. And I think this is just interesting to think about, that we found hot spots almost where I would have guessed. The low spot, the downwind in the low spot in Maui, and kind of the leeward-ish side of Lanai as well. Now this is just a snapshot, but what this indicates is unlike the rest of your debris, it is possible that the microfibers are actually coming from Hawaii. Most of the rest of everything that you get, you guys are a sink. You are really not thought of as a source at all, but it would be interesting to do some more work, and that's one of the reasons I'm here, is to help local Hawaiian organizations and students and community scientists collect this data so we can figure that out and then implement some of the solutions here on these islands. So another example of how this geographical data can be informative, there's Svalbard, again, on the top left. So Svalbard, and look where our hotspots were for the water samples. Like, the red shows that there's some people. There's no red. There's like one town in Svalbard. And yet, our hotspots were there. But when you overlay the currents, what you realize is Svalbard is at the dead end of the current that goes around the top of the Atlantic Ocean and becomes the North Atlantic current that goes over the British Isles, becomes the Norwegian coastal current, and just kind of stops at Svalbard. And so what that means to me is that all the people along that are linked to where the polar bears and walruses are, and the pack ice. And it's so beautiful, because I love ice. And I also, turns out, love walruses, which was unexpected. I didn't expect to have such a reaction to the walruses. Anyway, so yeah, I think it's good to know, to see this connection. And this is what some of our data do. All right, another quick game. Which of these do you think came from a beach in Hawaii, specifically windward side of Oahu, basically Kalama Beach or Kailua Beach? Which one?
Number 3.
Here, I'll give you the numbers. We're starting there. 1, 2, 3, 4, 5, 6. It's not 6, I'll tell you that. All right, we have a vote for number 3.
5.
5 is it. What was it that gave it away for the 5 vote? Any 1, 2?
Yeah.
Terry
Guess.
grew up there.
You recognize it.
Well, it looks like pieces of boogie board and
stuff like that.
Oh, that's
you know,
interesting. Oh, like the blue?
Yeah.
So for me, I'll tell you where these are from. So we've got a couple from the eastern side of the North and South Atlantic. So eastern side of the Atlantic, sort of down the, it's like no Europe on your map. Over here, it's like, oh my God,
There's no good diving there.
yeah, so it just doesn't need. It can be. It can fall off the edges. I mean, now I understand. Like Hawaii's fallen off the edges for most of them. Okay, so eastern, North and South Atlantic. So Portugal and Cape Town. The number 3 is a good guess in that it has a mix of old and new. So that's looking basically the junction of 3 oceans: the Southern Ocean, the Atlantic Ocean, and the Indian Ocean. This is Alicante, Spain, so in the Med. This one's Hawaii. And what gives it away for me is the things do look weathered. They look a little bit more UV bleached, universally, a little bit more homogeneous. And that's because you are a sink for this stuff. That it's traveling, well, that map is perfect. So now you've got like the circulation pattern, and you're the dead end. You're the dead end in this case. But this stuff has traveled really long way. All right. So some of the interesting items that are in these vials, and I've collected these all over the world. Resin pellets connect us all. It's very rare that I don't find resin pellets during a beach walk. The other thing is, you guys see these sticks? Anyone guess what the sticks are? I had to crowdsource it on Instagram because I didn't know when I first found them. I first found it in Portugal.
Big plastic Q-tips?
Yes, exactly.
Oh, they are?
Bingo.
Yes.
Yep. Yeah, so they are plastic Q-tip sticks. We pretty much have paper Q-tip sticks. Europe has still been using plastic ones, and they're being flushed, but the wastewater treatment system isn't supposed to take anything that isn't natural. And so when there are backups with wastewater treatment, these things, along with other non-natural things that get flushed, end up straight away they're in the perfect condition. They end up in the environment. And something that I learned, I was just in Edinburgh for a State Department thing, and I learned that only 70% of homes in Scotland, previously to someone working on this, didn't have a trash can in their bathroom. So just think about the consequences of not having a trash can in your bathroom. And how, this is low-hanging fruit though. And the amazing organizations with whom we met are working on it. And one of their initiatives was giving some people, all you need is something little to remind people that anything you didn't eat first should go there, you know? But what a fascinating bit of social science to solve another problem. All right, I'm gonna keep rolling, literally, pun intended. So what our solution, the one that we wanted to help spread the word is this. This is the Cora Ball. I know you've had your hands on one, so ready? Incoming, Cora Ball incoming. The Cora Ball is a device that you put in your washing machine. And it's designed to, you just put it in your washing machine. It was originally designed just to catch, but it turns out that it also reduces shedding in the first place. It was inspired by coral. When we couldn't figure out a shape that we liked, we thought, what do we need to do? And we realized we need to catch small things from moving water. And they were like, oh my God, coral stops and catches small things from moving water. That's what coral does. That's its job. And so that's how we got the design and shape. It goes in your wash. And this is what it looks like to kind of clean it, and when you get a fuzzball. Fuzzballs look more like hair, because just with your eye, it's all too small to see anything but like gray fuzz. All the fuzz looks gray when you put it together. And so we're gonna do this little video where we digital microscope it. That's hair, so you can see it's actually humongous. And those are all the little bits of fiber that are in this very small fuzzball. Stubby pencil coming, right there. So that fuzzball had all those bits of microfiber. So the Cora Ball helps to do two things. Other solutions sort of coming to the end here is, for us, education is a solution. So we have a great microplastics curriculum, a series of activities, not just for boys, but for girls. And because we're sailors and generally connected with sailing programs, we are delivering this as like STEM in the middle of a science program. So it's like kind of rowdy bikini science, which I love. I love that. And if anyone is a teacher or has teacher friends or wants lesson plans, they're available. We did it with the No Marine Debris program. Our cleanups aren't just cleanups, like I already said. We go beyond. So we dump the stuff back out, we look at what we got, we record it, we talk about where did it come from and why. We talk about, is this a behavior thing? And if it is, what causes behavior change? So we have these really great games that bring up discussions about what causes behavior change. We have really interesting people on board with diverse academic and professional backgrounds. This guy is a startup guy, and he's talking about what it takes to bring an idea to reality. We ask people to work on problems that inspire them, just like we were inspired to work on microfiber pollution. So these two are working on plastic bags because they chose them, not because they were assigned. We share our experience developing the Cora Ball. This is one of the earlier versions that it worked, but it couldn't be manufactured. It took 3 days to 3D print that, which does not a business make. So we had to figure out how you could, that concept that you could design and 3D print something that you quite literally cannot manufacture was new to us. So we share that concept. And we asked the participants to share in their own, what Nat Geo calls science telling, and they have to explain their inventions or their ideas. We don't even have people, not everyone has to do an invention. They could do a policy, they could do an art or messaging. We did travel with a 3D printer, so if someone did have a physical idea, we could make a little model of it. That's Dwayne, the sustainability turtle. That he was a messaging guy. So science telling is super important. And I'm going to finish with one more little guessing game for you to prove the point that while we do need solutions upstream of people, upstream of consumers, and we need corporations and governments to move the needle, that our actions also make a difference. So the game is how many pieces of 1 millimeter microplastic, so that's kind of huge, so that's like big enough to see, does one single-use beverage water bottle, would that turn into? It's not a million, it's low, it's much lower than a million, but give me a number, start any number that comes to your head.
1,500.
More than 1,500, appreciate the starting the guessing.
5,000.
I need more.
10,000.
More.
100,000.
Okay, less. And I appreciate the leap. So that's an incredible number of small pieces that one water bottle would become if left to its own devices, and maybe even more because 1 millimeter is actually still quite big. So easy to keep that from happening. I mean, the way I think of it is picking up microplastic at this point, until we have a microplastic magnet, is like spilling a salt shaker and then being like, go pick up the grains. You gotta just have a better salt shaker, one that doesn't spill. You know, so for us, we really are spending the vast majority of our time, pretty much all of it, on prevention. The cleanup needs to happen in a lot of places, but it for us is a tool to get to prevention. One more. This is a plastic grocery bag. Are they allowed? Banned? Do you have them here?
Banned in this
No?
category.
Good. So that, we just looked at our Vermont data, and since the bag ban in Vermont, our data show a reduction in bags in the environment. So this is an example of policy working. Not all policies work. This policy works. And guess how many 1 millimeter microplastics we all don't need to deal with being in the ocean because we're not using these anymore. One bag, give me a number. It's more than the last one. It's actually more than your guess.
200,000.
More.
600,000.
Okay, you guys are good, like right in the middle. Right in the middle. So these little things matter. That is a lot of microplastic that's not happening. And I'm happy to stick around to answer some questions before the next speaker gets rolling. Whether we do that here or in the shop, I'm happy.
We have a few more minutes, so does anybody have questions? Ross?
I have many questions, but I'll stick with one that I'm really interested in because I didn't realize that anthropogenic, I think you called it, like the man-made materials, cotton, things like that, were causing such a big issue. And I know that there's a huge push just in general away from plastic, away from spandex and all these other products. So what do you see as a solution to help us with, I mean, obviously we need, unless we all wanted to walk around naked again, so what can we do to both like not produce more plastic into the world, but also make sure that our naturally made clothes are not harming us and the environment as well?
Yeah, I love this question because it does show how difficult this is in sort of a good way. Okay, there's first of all a continuum. Just like there's a continuum of what do we do with the trash that we find. You know, there's landfill, which is like the worst, and then a little bit better would be like waste to energy, or incineration is a little bit better, and then waste to energy is a little bit better, and you have a continuum until you get to reuse. And that is all assuming less stuff. Like that's outside of this. This is you're just having less stuff at the beginning. But so there's a continuum with clothing as well. And so on the continuum, organic down to the dyes, everything is pretty good. Now that doesn't mean that a fuzzball of organic down to the dyes isn't going to fill up a little plankton belly. However, it's not going to do a whole lot of other harm. So there are optical brighteners, wrinkle releasers, and all sorts of other additives, heavy metals to set dyes that can be a problem, a toxicological problem within the anthropogenic cotton or man-made natural fiber zone. And so that would be in a sort of awareness there, but you're still on arguably the better side of the continuum, like the less harmful side. And I don't want anyone throwing your fleece away because of this talk. Better know that your fleece is more sheddy than other things, and wear it on the inside. So if you're going out, wear it at home. Or when you're going outside, put your low shed whatever jacket over your fleece, especially in a pristine environment. So we don't need more clothes in landfill, but maybe some strategery can help. The other thing is I, like you guys, really love outdoor sports. Your sport is not super compatible with natural fibers. I'm assuming your sport being scuba diving. I'm a skier, mountain bike, sailing, wing foiling, as much as I can do that's human and wind powered, and very little of that works with natural fibers. And so something that I support and that we're using our work to support is the development of resilient clothing, more resilient clothing. So say we have great, resilient, technological fabrics, and if you say technological, that means synthetic, breathable, stretchy, keep you warm, keep you cold, whatever. That is one material or that can be recycled. The other problem with some of this tech stuff is there's like 57 different materials, and there's some that are proprietary, and they just mess up the recycling stream. So, and then the other, and this is happening, is what if we could make technical performance fabrics that are bio-derived and bio-benign? How cool would that be? And it's happening. There are people making, I mean, like this much at a time still, because this is real cutting-edge innovation, but they're getting it, is like a Gore-Tex-like material from sort of compost type stuff, from naturally like waste even. And that's really hopeful. I got to be a judge in this microfiber challenge that a great organization called Conservation X Labs did. And it was all about upstream of consumers. It was about making better materials. And then when that exists, then we all are like, we want wetsuits that are the better version. I would like lycra, like legging things, like thermals that are made of something better. You know, other ways that we can all be part of the solution while we are still using synthetics, which I am, like we all have to pretty much. Exactly, I'm head to toe so I don't sweat to death, because for me 80 is like a lot. Is to wash in cold water, do 3/4 to full loads. That's like less garment to garment abrasion with the full loads. Most of you already have front loaders. When your machine dies, if you have a top loader, if you can go for a front loader, do. It causes far less shedding. Use the less spinny, less aggressive settings. Encourage people in your household to not wash every garment that ever like comes near their bodies. but only the dirty ones. Do wash the dirty ones, definitely. But the spot cleaning can be a thing. I was just speaking to kids in Oahu, and we collectively say sometimes you put something on after bath, but before pajamas, and as long as you don't drool on it, that can go back folded nicely into your drawer. That doesn't need to be laundered. And they sort of looked at me a little bit like askew, but they're like, yeah, like if you drool on it, wash it, but like otherwise, you're good. So yeah, so I appreciate that question.
Thank you.
Just you're working on the
We
continuum.
have time